If you proceed, you will see that excess of f becomes, we keep 1 by ts as it is, summation. We know very important property of impulse convolution from signals and system. This property says that when you convolve any signal, let's say x of t convolved with del of t, convolution of x of t and del of t will be nothing but x of t. So if when you convolve any signal with del of t, you get the same signal back. When you convolve any signal with shifted impulse, x of t convolved with t minus t naught will give you the same signal, but that signal will be shifted by the same amount. So you get x of t minus t naught. So this is an important result that we know from signals and system. Now this is valid in time domain. This is also valid in frequency domain also. So you can see here we are taking convolution of x of f with shifted impulses f minus kfs. It's a shifted version of the impulse del of f. So when you take the convolution, x of f will also get shifted by the same amount. So coming back to the expression, we will get the convolution result as x of f minus kfs. So by whatever amount del of f is shifted, by the same amount x of f will also get shifted. K will have the same range. So you can see suddenly the sampled version of the signal has a Fourier transform. The Fourier transform of the sampled version of the signal is in the form of the original frequency spectrum x of f. And what do we observe is, if I keep that 1 by ts outside, and if I just expand this summation for few values of k, let's say if I put k equal to 1, first I put k equal to minus 1, you get x of f plus fs. If I put k equal to 0, I get x of f. If I put k equal to 1, I get x of f minus fs plus dot dot dot. So you can see original x of f is present as it is, and it gets added with the shifted versions of x of f. This is the version shifted towards right by fs. Shifted right by fs. This is my original x of f, not shifted, present around the origin. Now this x of f in the form of x of f plus fs is nothing but shifted towards left by the same amount fs. And there will be so many shifted versions of x of f by fs. So we conclude that the Fourier transform of sampled version of the signal is nothing but the original frequency spectrum and all the possible shifted versions towards right and towards left by the amount fs, 2fs, 3fs and so on. So if I now come back to the previous slide, you can see that we are now in position to draw the frequency spectrum of the sampled version of the signal. So let's draw the frequency spectrum now. I repeat, the expression that we have got is nothing but the original x of f, which is being repeated by fs on both the sides. So if I draw the frequency spectrum in this third waveform, we will have original x of f as it is. So this original x of f, I'm going to take it as it is in this third diagram. So you can see original x of f comes out as it is between minus fm to plus fm. Now the next expression is the shifted version of x of f towards right by fs. So the next x of f will be available around fs. You can see 0 will shift to fs. This point fm will shift to fs plus fm, and point minus fm will shift to fs minus fm. So the exactly same triangle, which is the original frequency spectrum, will be available on the right hand side shifted by amount fs, and also by on the left hand side shifted by amount minus fs. So in simple words, whenever these impulses occur in the frequency spectrum, around every impulse we will have one original frequency spectrum available. So as you can see, the original frequency spectrums are shifted on both the sides. The one that we have on the right hand side will be present around fs, so this will be fs. Point fm will be present at fs plus fm, and this point will be present at fs minus fm. Similarly, the left hand side spectrum will be present around minus fs, so this point will be minus fs plus fm, and this point will be minus fs minus fm. And these are not the only three spectrums. We will have continuous repetition of these spectrums taking place on both the sides. So this is what we call the frequency spectrum of the sampled version of the signal. This is excess of f.